Distinguished guests, partners, ladies and gentlemen, สวัสดีค่ะ Good afternoon. Welcome to SmartLi DC Backup Power Solution webinar. My name is Tanya. It is a great honor to be your host today. In this beautiful moment, we are glad to have customers from all regions around the world gathering for the webinar. Before this webinar, I wish you all a Happy New Year. Thank you very much for participation and welcome. Now, let's warmly welcome Mr. Steve Kim, Vice President of Huawei Digital Power APAC, to deliver an opening speech.
Good afternoon, ladies and gentlemen. I'm Steve Kim, Vice President of Huawei Digital Power, APAC. On behalf of Huawei Digital Power, I would like to express my warmest welcome to all of you present today at our SmartLi Data Center Backup Power Solution webinar. Carbon neutrality has become a global consensus and shared mission. In the next 30 to 40 years, low carbon, digitalization, and intelligence will be the certain trends. The decarbonization goal in the context of the energy industry is about clean power generation and electrification of energy consumption. The extensive and profound economic and social transformation will not only bring new challenges to energy production and consumptions, but also bring new opportunities to industry to reach the next level. With the accelerated arrival of intelligent world and the vigorous development of digital economy, computing power and data has become key production factors, and the world has ushered in a surge of data flow. According to the Intelligent World 2030 report, it is estimated by 2030, general computing power will increase by 10 times, while the artificial intelligent computing power will increase by 500 times. The explosive growth of data volume and computing power has driven the development of high-density and large-scale data centers, opening new growth space for the development of data centers. It is estimated that by 2027, the global investment in data centers will increase from the current $35 billion to $54 billion. In pursuing of carbon neutrality, digital economy has put forward higher requirements for data centers such as intelligence, green and low carbon, as well as sustainable development. Currently, for data centers power supply, lithium batteries have great advantages in space saving, energy saving, and emission reduction. However, the cost, energy saving, as well as the security of lithium batteries become the main concerns. By the end of 2022, 91% of the world's lithium battery production capacity are in Asia-Pacific region. Asia-Pacific is an absolute leader in manufacturing and the application of lithium battery. In data center field, starting from 2019, the top 40 large-scale colocation data center providers in Asia-Pacific are using lithium batteries. What's the backup power solutions? A large number of financial, government, transportation, and manufacturing industries have also begun to fully adopt lithium battery solutions for the backup power requirements of the key power supplies. According to the latest Sullivan Data Center Lithium Application Analysis Report, the data center lithium battery market share has increased from 15% to the current 33%, and it is expected to surpass traditional backup power solutions such as lead-acid within 2 years. Facing huge challenges and opportunities, Huawei Digital Power will continue to increase investment in digital and power electronics technologies, especially in the field of data center facility. In terms of R&D, we attach great importance for future investment. In 2021, Huawei's R&D investment hits a new high, which is accounting for 22.4% of revenue. We will continue to leverage the advantages of integrating digital and power electronics technology to develop solutions for large-scale data centers, small and medium-scale data centers, and key industry power supply scenarios, helping customers to build low-carbon and intelligent data center from the whole process of construction, energy consumption, operation, and maintenance. Nonetheless, efficiency and reliable key power supply assurance also makes partner service easier and sales more efficient. At this webinar, we will discuss with all parties that development trend and the application direction of lithium battery technology to help the data center industry achieve future-oriented, long-term, sustainable development. Finally, we hope to work with our customers and partners to seize the opportunities of the digital era in Asia-Pacific region, continuously elevate and improve capabilities, and jointly lead the vigorous development of the data center industry. Thank you.
Thank you, Mr. Kim. Now, let's welcome Associate Professor Dr. Montri Wiboonrat, BICSI Thailand Country Chair, King Mongkut Institute of Technology, Ladkrabang Business School, Bangkok, Thailand.
Hello everyone. Before we start the section, may I introduce myself? I'm Associate Professor Dr. Montri Wiboonrat. I work as full-time lecturer at KMITL Business School, Bangkok, Thailand, and I serve as BICSI Thailand Country Chair and the Data Center Standard Committee for Engineering Institute of Thailand under His Majestic King Patronate, or we call EIT. And I work as a president at the Waste to Energy Trade Association. And I serve as the committee of ITME Power and Energy Society, or PS Thailand. And I'm also the founder of the Data Center University.org. As when you look at this website, you will see all the detail of the data center, all the technologies, or include about the technology that related to the data center. This website is used for my master, my PhD student, or even though open for everyone can get in if you would like to know more about data center or even though any data center standard. Okay. Today we will going to discuss about the development trend of battery technologies. That will be a quite interesting topic at the moment, because right now many new generations of the EV cars coming, or the bigger data center, they need the battery to back up to protect their failure of the power system that will cost a lot of money to the data center. So the agenda for today, we will discuss about the trend of the battery technologies. We talk about lithium-ion market, We talk about sustainability, efficiencies, and environment of the battery as well. And we try to look at comparisons between lithium vs lead acid battery. Even though the lithium vs sodium ion battery, that is the latest, the new ones coming. At the end, we will talk about the evolutions of the new energy storage technology trends. When you see about the industrial trend that the global energy storage capacity is expected to exist in 2000, it's already past that point. When you see all this one, like growth in market about the electrical power, like data center UPS, or even though the communication size back up, even though the 5G is coming or IoT. On another, talk about the transportation fields, many EV, like bus or contractors, or even the personal car is coming. So the requirements, as you know, Tesla, BYD, or Great Wall, or everyone. Or another to be talk about consume electronic and power tools, like in the market, like laundry or drillings, machine saw chains, or lawn mower, or even though another equipment need battery anyways. And at the same time, the forecasting about transportation and for the power energy sector are growing as well. We see on this picture from 2020 until 2025, the growth rate for transportation is coming as EV, as we already knew about this trend, or even though we talk about the electric energy as well, the trend will go up as well. So when we talk category trends, like we call LFP, or stand for lithium phosphate, or we call LFP, is still main apply the chemistry system for energy storage, exchange energy density, and life cycle are the main research directions. When you look at this graph, you will see it about mature products and in development, mostly like phosphoric acid, iron, lithium will be here. So they have gained more the lifetime, like more than 5,000 times. And when we talk about energy density, it's much more than 280 kilowatt per kilo. And the sodium battery is here, and the lead acid is here, you see. So we jump from this lead acid battery to the phosphor LFP, and the new coming is sodium battery. And when we look at the energy density and life cycle life are the main research direction from the lithium ion phosphate, what we call LFP system in the future. You see from 2020, the density will be only 140 kilowatt. And for 2022, increasing 160, and on 2024, 120, and 2026, 180, and 2018 is 190. But for the life cycle, it will be 600 times up to 800, or sorry, 8,000 times in 2022, and will be 10,000 in 2024, and it will be 15,000 in 2028. So you will see about the efficiencies. In 2020, only 70% efficiencies, and for 2022 will be 95% efficiencies, and in 2028 will be 97 efficiency. So they have evolutions about the technology anyway. So when we getting competitive, we discuss about battery price seem reaching key level for 100 per kilowatt hour by 2026. You will see this, the black one will be actual lithium ion price is still higher. In 2010, we have 1,000 kilowatt hour, but we expect right now, we've been in 2020, will be around 100 kilowatt hour, but for 2030, it will be below than 100 kilowatt hour. That's the reason all the EVs coming. So for the global demand for the lithium-ion battery will be over 3,100 gigawatt hour in 2020. So the market demand for the lithium will be increasing dramatically from 2019 until 2030. You will see about the annual growth rate will be increasing. Mostly we will see on this one will be all the passenger transportations. As we know, the EV becoming because of the gas and oil price since the Ukraine and Russia war, the price of gas and oil soared up, maybe double, or in some country maybe 5 times, depend. So many people will move away from gas and oil or internal combustion car. So that the reason of battery is coming. So when we see the lithium-ion battery market, so we have many different kind of the material that we use for battery, like lithium cobalt oxides or LCO, or lithium nickel cobalt aluminum oxides, or even though the lithium ion phosphates that mostly we will target on the LFP, or even though lithium manganese oxide, or lithium nickel manganese cobalt, or lithium titanate, or LTO. So all trend of all the technology is going up to 2030 when we see from this picture of this graph. So when we look at the battery, we talk about sustainable efficiencies and environment. They have main factors that determine battery efficacy, include like raw material availabilities. So that's why we have a lot of the lithium ion material. And cost, that means cost per kilowatt hour. As you know, since 2020, the cost per kilowatt hour should be less than $100. And life cycle, that means how long that the battery will still have more efficiencies. And energy density, that means can make it smaller, and what the material can answer on this. And safety is the main factor as well, because of, since you know, when you get on the plane, they will ask about a power bank that we're not allowed to bring. So they have flammable, that we talk about safety of life. And even though the temperature for operational range, as you know, the lead acid, they have limitation about the operations range. If the temperature increase, the lifetime of the lead acid battery will decrease half lifetime as well. That will be, I will not get deep into the technology and technical. When we compare with the lead acid battery and lithium battery, it will save about 38% of the total cost of ownership. This will be test long 15 years between lead acid and lithium ion, and lithium ion with the on-demand expansions. They use the UPS system, that means for palm 500 kV, and 2N system, that means redundancy system, 15-minute backup. The lead acid solution is replaced once every 15 years. The power of multi-cabinet is about 5 kilowatt. The capex is about $7 per watt. The phase deployment will be 5 years, 20% of each year. You will see the graph compare between the total cost of ownership comparisons between the lead acid and the lithium ion is here, and the lithium ion with on-demand expansions throughout 15 years. So it seems to be the on-demand expansion will be the advantage. The next, we try to compare the lithium ion with the lead acid battery. Over here, you will see about the lithium batteries here. The voltage is equal, the capacity is semi the same, and we talk about the charge efficiencies. The lithium ion is almost 95, but it is only 70%. actual charging times, same. Electrical price, same. And the annual cost, you will see as here is different already, 800 something and 1,400. And the annual maintenance cost of lithium will be zero. Or maintenance cost for 10 years, we see that this number is quite big, 8,000 something with 28,000. So the total cost compare, we try to plot the graph out. Within this, we will see the lithium-ion will be not increased more per years, but when compared to the acid, because of it's higher. So normally the lead acid 15 years, we have to change anyway, but the battery will have cost a lot. So we still compare the lithium-ion versus the lead acid battery. This we take about two model compare in terms of total cost of ownerships. We talk about 2,000 kilowatt VRL, we call Wang regulated lead acids with the battery management system versus about lithium-ion solution that we have to the BCL4 and BCL6. BCL4 is combined. We have calculation on the 15-year lifespan based suit for 2 to 20 minutes run times, and BCL6 combined, we talk about 20 years lifespan, same at 2 to 10 minutes run times. If we see the graph for the LC6, it is steady here and lower. So for the lead acid, you will see from the beginning of the 4th year, the price will increase for the TCO. So this will be compared at least for 12 years. You will see the difference between 3 of them. Next, we step up to compare another. We have the lead acid battery here. We have the lithium-ion battery here. We have sodium-ion battery. That is the new one that we talk about. So for the cost, it will be low here, right? When compare energy density high here is on battery lithium-ion, and the sodium is more moderate or even high. The safety here is very important because lithium-ion it can flammable and exposure, but for the sodium ion battery is very safety. You see the lead acid is toxic. This will be a scratch, and the sodium ion battery is earth abundant. That means you can have make it cheaper in the future. The life cycle, the efficiency is less than 75%, but for the lithium, it's more than 90%, same as here. And the temperature range, you see this minus 40 Celsius to 60 Celsius is minus 25 to 40. This will be on the lithium-ion battery, but for the sodium-ion battery, we can range for minus 40 up to 60 Celsius. That means in the future, we may don't need more temperature room for them as well. Next, we talk about compare between the lithium-ion battery and that Na on this sodium-ion battery. The toxic material you have to working on the disposal as well. For sodium-ion is non-toxic and environmental friendly, and for the flammable, lithium-ion is still flammable, but sodium-ion is not friend, is not exposure as well when compare. Cost in the future, because as you know, sodium-ion battery is a bundle battery on the earth. So it will be make it cheaper in the future in the mass productions, and complexity and fabrications is more easy, and life cycle can be longer as well. So we come to the short backup time and the short and long backup time. So traditional backup for 5 to 10 to 20 minutes backup, the value is mean they are used to back up waiting for a generator to starting up and then supply to the load. That means the generator, we can take about 15 seconds to start up, so battery can handle at the first time. But another we use for the grid peak shaping. That means they used to daily cut of the lithium-ion battery to achieve the lower electrical fee that when something happens, we can cut off the peak. And for the load peak cuttings, that means in the data center, the annual PUE, the energy storage clip the peak load efficiency, reduce the peak PUE, and improve the IT power usage rate. And for the grid frequency, we use this to electronic transaction stack shortage, like half an hour to 1 hour participant to electric power transaction, and the fast frequency reserve or FFR, and the consumer fee or charge like plain electricity. For the medium volt energy storage system, we place to the low voltage battery. When we see this one, the campus stacking energy storage 20-foot container that equal to 2 megawatt energy storage container. This one will be optimized we call low rate cost of storage. So in the future, many data center, they will have this kind of things to support, like EAS connect to the power conversion system and then convert to transformer and then tie it back to the IT or the data center. This will reduce the LCOS by 10%. This will be a distributed access architecture that many we call edge data center we have to require on this solution in the future. For the evolution of the new energy storage technology and trends, when you look at this picture, they have two axis, like on x-axis will be about energy storage power that we talk about 1 gigawatt or 1000 megawatt, or another we talk about storage time, that means how long we can support. So the supercapacitor will be here, like 10 megawatt, and maybe just a second of flywheel energy as well. They can grow up into 10 megawatt and they can spin like only 1 minute. But for here that we are talking about energy storage, that we use the lithium battery or even though the sodium battery, we talk about a day that we can back up maybe 15 minutes to 2 hours. Then we can go up to 100 megawatt as well. But for a day, we have to talk about the compressed air or even though pump energy storage or liquid flow cells, or even though the highest one, we talk about hydrogen or hydrogen carriers that can up to 1 gigawatt. And we talk about a week to supply. On another, we talk about the commercialized, normally the lithium-ion battery or liquid or lead acid battery is here already. They are predecessor. But for the sodium-ion battery, it's on the demonstrations or application phase. As you know, I think next year they have many company, or even though in Thailand we have a plant like for the sodium-ion battery to serve in the market. So this will be the trend that will be happened. So the hydrogen will be answered in the future as well. I think many companies, many countries, they're looking for the hydrogens to make like a backup, like from the renewable energy to electrolysis process, and then they got hydrogens and oxygen, they storage the hydrogen as energy storage. And when you request, we can use the hydrogen as a source of the power or source of energy storage in the future. I think that's all for my presentation for today, and thank you. If you have any information queries, you can contact me by the email like montri@kmitl.ac.th, or even though my phone number here. Okay, thank you. สวัสดีครับ
ขอบคุณค่ะ Thank you, Dr. Montri, for sharing us about the development trends of lithium battery. With 20 years experience in research of digital and power electronics technologies, Huawei Digital Power is committed to become the most trusted partner for data center. Mr. Johnny Wang, DC Power Senior Marketing Manager, will bring the Huawei SmartLi 3.0 solution Let's welcome Mr. Wang.
Ladies and gentlemen, welcome to Huawei Asia Pacific Summit. It's my honor to have a presentation of SmartLi 3.0, digitizing your power. I am Johnny Wang from Huawei Data Center Facility, Marketing Department. As we are stepping into the cloud era, the data center facility has faced a lot of challenges. So among the power facilities, the battery has been an important role. It faced 4 main challenges nowadays. As we all know that the batteries has occupied around 10% of the whole power space. And 5 to 7 years lifetime cannot match up with the 10 years lifetime of the transformers, PDUs, and UPSs. The old and new battery cannot be mixed used. So we need to add all the batteries on site. It will cost a lot of invest in the CapEx. And it's a lack of management. So we have to add more BMS systems outside of the lead-acid batteries. The Asia Pacific has leading the world in the application of lithium-ion batteries. We have got the benefits of only 30% of the footprint and wait 10 to 15 years lifetime, the built-in BMS and no hydrogen generations. So as the third-party report shows, there is around 24% proportion of lithium-ion batteries in the whole battery market, and it forecasts that the data will be 42% in the year 2026. And the lithium-ion battery will be not only used in the UPS part, but also used in the energy storage. So in the data center facility, the energy storage can use to the peak shaving. It's like to use the different electricity fees of the peak and valleys. And it can help to cut off the peak loading, which means we can reduce the peak PUE and to help to move more power to the ITs. So based on these applications and the trends, Huawei, we have released the lithium-ion battery for over 5 years. And now it's come to the 3.0 version, the ST and LT. The ST is short backup time, typically 10 minutes or 15 minutes. The LT is long backup time, typically half an hour or 1 hour. They have different discharge rate and designed for different scenario. And the benefits and features are almost similar. They can support a safety, a lower TCO, and higher availability solution. Both of them use LFP as the stable battery chemicals. They have built in the predictable IBMS and pack-level fire extinguishing systems. And they can get the same value of the lifespan, the footprint, and the weight. And more digital technologies and smart ways are designed inside to increase the high reliability. It can support the group-based capacity testing. The old and new battery can be mixed use. And one module failure, it can support module tolerance. So later, with the next slides, I'd like to show the details of Huawei SmartLi 3.0. Okay, the following slides, I'd like to show the feature of SmartLi 3.0 in two aspects, safety and smart. The first way to achieve high reliability is using the lithium iron phosphate LFP battery chemical. Compared with other battery chemicals, LFP has more stable alive-like structure. It has higher thermal runaway temperature of 480 Celsius degree, which means it will not touch thermal runaway in the lower temperature. And after thermal runaway, it generates less heat and no oxygen. The extreme puncture test has been done. This test is used to short circuit the inside positive and negative parts. And after the short circuit, many heat was generated. And the left video shows only smoke but no fire, no explosion of LFP. But LMO, it will catch fire after smoke and explosion after fire. We have done a lot of tests based on different conditions, different types of chemicals. The results showed LFP is really the most safer battery. And in the past several years, more and more vendors and suppliers in the industries, they use LFP as the batteries in the data center or in some other critical power systems. But it's not enough to use just safe battery cell. The BMS system is also very important. Huawei IBMS system in SmartLi has 3 layers. The first layer is to manage the cell's voltage, temperature, and current. And it will upload the information to the second layer. The second layer, BCU, manage all of the BMUs. It will generate some alarms and do some protection or protection. And some unique feature like the mixed use of older and new batteries and the fault tolerance of the battery packs are achieved in this level. And this level also uploads the information to the third level, the SBCU. The SBCU is the level to manage all of the racks and to manage the communication between the racks of battery to the UPSs and to the NetEagle systems. The state of healthy and state of charge are managed in this level. And also it can store the logs, the historic alarms in this level. So because of the lithium-ion battery in the data center, there are many cells. There are more cells in. So we need to use this IBMS with 3 layers BMS system to manage all of the cells operate under a very reliable condition. But we still face another challenger after the best cell and best BMS. So this is a challenger of thermal runaway. The trigger of thermal runaway is the internal short circuit. And when we design the protection ways, we analyze there are 2 types of thermal runaway. The gradient type with a long time duration and the burst type with a very short time. So for the gradient type, we designed one way called the internal short circuit protection. because in a very long time, it will have some diaphragm breakages, the defect, and metal particles inside of the battery cells. It will have really leakage current inside of the battery cell, but it's not visible. And very real heat will generate in these durations. But we can use the data collection, and we can, detect the current, the voltage, and temperature during the charging and discharging moments. And we can use these data to build a distribution statistics and to build a self-learning mode, discrete value detections. And many more exception factors can be obtained. And a formula can calculate the value of the exception factor. And the risky cell can be chosen. So after a very complex logic inside, we will show the risky module or cells inside of the website and the LCD screen to remind the engineer to replace it. So this is a way to predict the gradient type internal short circuit. So how about the burst type short circuit? We have this way, the built-in pack level fire extinguishing system. Because the burst way, it happened only in some emergency ways. So only the fire extinguishing system can protect the battery. We use Novak 1230, and it can be tricked when the temperature rises above 119 Celsius degree. We have done 2 tests, outside of the cabinet and inside of the cabinet. Both of them shows there is no fire spreading and no influence on the other packs. And also it's not easy to trigger the battery, to fire the battery. So we have done this test in the third-party organization and to manually rise temperature to some runaway and manually ignite. The result shows it can be tricked in around 15 seconds. The fire can be cut off. So we have these 2 ways, the internal short circuit prediction to solve the gradient typer and the pack level fire extinguishing system to solve the burst typer. The previous slides, we have many ways to keep the SmartLi 3.0 a very reliable system. So later, the slides, I would like to share some ways to make SmartLi more smart. The first way to make it smarter is to achieve mixed use of old and new battery. It's not available because in the industry, they just parallel the old and new battery. They will influence with each other, the large bias current. But for Huawei solution, we use the battery management module, control module, to control the current separately and intelligently. For example, we have the left photo here. It's a 300 kilowatts, 10 minutes for the first phase. And we use UPS 5000 with 3 100 kVA power modules. And 2 cabinets of SmartLi 3.0, but only 1 cabinet is configured with the battery modules. And after the load goes higher, we can expand online. And 3 more UPS power modules are added. And 14 more battery packs are added too. So in the right photo, the blue modules and the orange modules, they can operate together, especially the battery packs. The system can control the charge and discharge current based on the state of health. It's not just the theory. We really did the test. The left figure shows the imbalance current of the SmartLi 3.0. We find that from the starting point to the ending point, all the discharging duration, the imbalance current is only 2% to 5%. However, if we parallel directly of the batteries, imbalance ratio will touch 10% to 25%. It has several problems. First one is the imbalance current will cause the overheat of the cables. Secondly, like the green curve shows, it may trigger the overcurrent protection. If one cabinet is overcurrent, the rest cabinets are overcurrent too, because the rest modules or cabinets can't support such higher temperature, higher current. So we need to keep the imbalance ratio lower. That is the principle of the intelligent battery management module. We just control the current based on the state of health. And in this way, we find another principle to control the voltage. By the same module, we can boost the voltage with one less failure module equal to the rest strings. For example, if this battery module is failure, we can move it out, and to reconnect the string, this cabinet can keep operating. But for the industries, if there is no voltage boosting, the whole cabinet is failure. So it can help us to keep a very long time for the backup to come to site, because the battery of lithium-ion cannot be transported by airplane. So this is the way we call the adaptive and voltage and current management. And this is also a very core patent technologies. So another way we are partnering is the testing of capacity. We know that when the battery is getting older, we need to test the capacity. But normally we have to rent a fake load and to reconnect the cables, then to charge and discharge the battery as a whole. It has a failure risky when the power is off and the battery is empty, there is no power. So we have this group-based automatic capacity testing. It has the benefits of, firstly, anytime only one cabinet is empty or is empty. So even at this time the power is failure, no risk here for the IT load. Secondly, no need to rent any fake load. The battery can be discharged directly to the IT loads. And also no need to discharge manually. The whole system can discharge automatically. It can help us to save the label and save the time. So the previous slides are all what we can do through the IBMS of SmartLi. And IBMS can do more features. It can detect the every parameters of every cells and calculate the state of healthy state of charge precisely. And what's more, it can have a communication between the UPSs and the SmartLis. And the UPS can also join the BMS system. It can trigger the breaker of the lithium-ion battery if the UPS finds some emergencies. And also it can manage the battery terminal voltage and current. So it's actually a tolerance of the battery BMS. So this is what IBMS can help us to make the SmartLi 3.0 more smart. And now in the industry, it's not only the new site, and more older sites need to replace the lead-acid battery to lithium-ion battery. there is no need to replace all of the batteries and UPSs because Huawei SmartLi 3.0 can support not only Huawei UPS on market, but also Huawei older UPS on site and the third-party UPS on site. So all of them are supported by SmartLi 3.0. And in the past 5 years, the SmartLi has been widely applied in the data center facilities. We have delivered over 250,000 packs and over 15,000 cabinets are delivered. We served over 500 customers. And we got a lot of certificates in the global, like the IEC, UL, and the CE. And I believe that SmartLi 3.0 can help you to build a very competitive, very reliable, and a very smart solution. So this is the end of my presentation. So thank you very much.
Thank you so much, Mr. Wang. Now we have a deeper understanding about SmartLi 3.0 solution. Ladies and gentlemen, now it is the time to take a break because we have arrived to one of the most exciting highlights, Lucky Draw session. Again, please do not hesitate to leave your questions and comments here. Congratulations for all lucky winners! Now, please allow me to introduce you our next guest speaker, Mr. Hwang, Senior Researcher of Korea Data Center Efficiency Association.
Good afternoon, everyone. My name is Hwang. I'm a senior researcher at Korea Data Center Efficiency Association. Before we begin, I would like to thank Huawei for giving me this great opportunity to present before this audience. I'll be presenting about current data center market in Korea and the recent events regarding the battery issue. Here is the series of contents that I'll be covering. First, I'll give a brief overview of Korean data center market, from the basic introduction to the key players currently in the market. Next, I'll talk about the current market volume, growth, and the data center capacities by region. And last but not least, I'll be touching upon the recent data center issues we had in Korea, what has caused the event, and what it will be like in the near future. All right, what is a data center? Its formal definition, according to the Ministry of Science and ICT, Article 40, it is a facility that integrates and manages multiple info communications infrastructures in a certain space to provide information and communication services. The actual definition that I believe that serves its justice is that it is an infrastructure that provides necessary electricity and air conditioning to dedicated buildings 24 hours 365 days throughout the year, with its mission to serve safe and efficient supply to maintain uninterrupted services. They house and networks most critical systems and are vital to business continuity and operations. Consequentially, the efficiency, optimization, reliability, and security of data centers and their information is a critical importance to today's businesses. They're also an essential infrastructure for a hyper-connected, intelligent society responsible for storing, processing, and distributing the immense data generated daily and globally. Let's take a quick look at the diagram on the left. You will see what we call a cloud data center, which is a hyperscale data center. Then right below the hyperscale, you'll have a local data center, which can serve as an independent data center or as a gateway between the edge data centers and the hyperscale data center. Edge data centers consisted of edge networks will serve much in a local manner. So the future of data centers seen on the diagram will be divided into hyperscale data centers for cloud computing and edge data centers for edge computing. Next, we have the structure and players. And by players, I mean companies currently in the business of data centers in Korea. On the diagram to the left, you will see that at the raw structural level, you have electricity or power coming from KEPCO, lighting and running, the DC, and the network coming in through telecommunication service providers, such as KT, LGU+, or SK Broadband. At the service level, it can be separated into three large parts. You have data center operators, you have data center tenants, and data center owners. First, you have the DC operators. We have companies like KT, LGU+, SK Broadband, LG CNS, and etc. And for global companies, we have Equinix, Digital Realty, Actis, ST Telemedia, Digital Edge, One Asia, and SC Zeus. On top of that, more companies like DC Bridge, Aegis, and Quoranco are joining in as operators. Next, you have DC tenants, who are cloud service providers. We have companies like Naver, NHN Cloud, and for global companies, we have AWS, Microsoft, Google, Alibaba, and Tencent. And lastly, you have DC owners, who are also cloud service providers. We have companies like Naver, NHN Cloud, Kakao, KT, and for global companies, we have Microsoft. This is a data of domestic data centers and their locations. There are 17 data centers in the region of Seoul, 17 data centers in the region of Gyeonggi, and 1 in Chuncheon and Busan. There are a total of 36 domestic data centers as of now, and out of those 36, 34 of them are in Seoul or around Seoul. This is the data of global cloud service providers and their data centers in Korea. There are 8 data centers, and almost all of their data centers are located in the region of Seoul or Gyeonggi. Additionally, companies like Actis, Stack, One Asia, and Perion are either currently planning or in the works of establishing a data center in Korea. And it is important to note that future foreign data centers will most likely be developed in Korea. By 2026, approximately 29 new commercial DC construction projects will be planned and pursued. And the investments from these DC projects will reach more than 12 trillion Korean won, approximately $8.4 billion US dollars. With compound growth rate of whopping 50%, the DC capacity is estimated to require over 1.5 gigawatts by 2026. It is important to note that the number for the data centers are only based on the industrial size co-location data centers. This is a more detailed graph of DC capacity. If you look closely, the highlighted area shows the spikes in capacity. From 2015 to 2016 marks the entry of global CSPs in Korea. 2019 through 2021 marks the entry of data center REITs in Korea. This is a diagram showing the estimation of data centers by region. It is important to note that despite the saturation in Seoul, the concentration in Seoul and Gyeonggi will only rise due to the accessibility of the geographic location. The reason behind concentration near the Seoul-Gyeonggi area are the abundance of higher quality of electricity, easier to reach based on geographical location, and relatively easier hiring as a workforce is concentrated within the region. Now that we have covered the current data center market in Korea and its rough projection, we will talk about the main issue, batteries. Recently, one of the most controversial news regarding the data centers was the fire that occurred on October 16th of last year. It was one of the biggest news related to the topic of data centers in Korea. The lithium-ion batteries were blamed for the fire behind one of the tech giants in Korea. Since the lithium-ion battery was blamed for the data center fire, the Korean government started doubting the safety of utilizing them and pressuring to put regulations and extra safety measures. Next, these are the major types of batteries used in data center UPS. And out of the four, lithium-ion batteries are widely used due to its reliable performance against the others. However, when charging and discharging, it creates massive amount of heat. And this heat alone, or any external force, may cause fire. The problem with it is that lithium-ion batteries, when caught on fire, is extremely hard to extinguish. Lithium iron phosphate, on the other hand, is known to have 4 times the battery life and is much safer. And as a recent fire has the Korean government actively seeking the substitute of lithium ion, lithium phosphate might just be the solution. That marks the end of the presentation. Thank you very much. And if you have any questions regarding data centers or data centers in Korea, feel free to email me on the address below.
Kamsahamnida. Thank you, Mr. Hwang, for sharing us. Thank you, ladies and gentlemen, and all the speakers as well for fulfilling afternoon. Thank you for the unreserved sharing. This is the end of the webinar, and we are looking forward to see you next year. ขอบคุณค่ะ